This video demonstrates the Awels platform called S02E06, which is an AI-powered application modernization platform. The platform is built around artificial intelligence and is designed to streamline the entire modernization process. S02E06 is structured around 4 key modules that work together to transform legacy applications. Let me walk you through each of these modules and how they contribute to the modernization journey. The first module is our discovery engine. This is where everything begins. We start by connecting to a Git repository, and from there we can immediately begin the AI-assisted analysis process. This module performs comprehensive analysis across multiple dimensions. It analyzes source code, examines documentation, and processes multimedia elements to build a complete understanding of the existing application. Moving to the second module, we create what we call an application twin. This digital twin serves as the complete digital incarnation of your existing application. It captures all the essential characteristics, dependencies, and functionalities of the original system. The third module focuses on reverse engineering through retro-documentation. This process reconstructs the technical documentation and architectural insights that may have been lost over time, giving you a clear understanding of how your application works today. Now, there's a fourth module that isn't included in today's demonstration but will be available soon. This upcoming module will handle the development of the new modernized application, completing the full transformation cycle. What you're seeing on screen right now is the main entry point to our dashboard and the 3 currently available modules. The dashboard provides a centralized interface for managing all your modernization projects. At the bottom of the screen, you'll notice the current status overview, which shows real performance data from our platform. We've successfully analyzed 47 applications to date. Our analysis success rate stands at an impressive 89%. The average analysis time is approximately 2 hours and 20 minutes, demonstrating the efficiency of our AI-powered approach. Currently, we have 24 active projects in various stages of twin creation and reverse engineering. This comprehensive approach ensures that organizations can modernize their applications efficiently while maintaining full visibility into the process and outcomes. Now we're switching to visualize the modernization activities dashboard. This gives us a comprehensive overview of everything that's currently happening in terms of modernization activities within the platform. At the top, you can see our active modernization projects and the number of analyses we've performed. Currently, we have 12 total analyses, with 3 still in progress, which means we've successfully completed 9 analyses. You'll also notice the number of twin deployments that have been realized. We have 6 completed deployments with 2 additional ones scheduled for implementation. Application Portfolio Overview. The dashboard provides a comprehensive view of applications currently undergoing modernization. The first application is our Oracle system, whose analysis has been completed. We'll explore this in detail shortly. In the Discovery section, you can see the TinyBlock application, which is written in Smalltalk, while our Oracle system uses PL/SQL. For TinyBlock, the twin has been created but hasn't been deployed yet, meaning its knowledge base has been successfully generated. The Mandrake application shows that the GitHub twin is currently being prepared and is ready for deployment. Finally, the Order Management System has completed its deployment entirely. Performance Analytics and Team Management. Behind this synthetic view, we have more specific insights. The reporting section shows a 5-week overview of what has been accomplished, what's currently in progress, and the planned budget allocation. You can see the efficiency metrics for our different teams: Team 1, Team 2, and Team 3. For example, Team 1 has 3 assigned projects with 2 completed, achieving an impressive 85% completion rate. Dashboard Customization and Templates. The platform allows complete customization of dashboard configurations based on your specific needs. You can modify different widgets and manage platform performance settings. We also provide modernization templates where, for instance, banking applications can transition from Java Spring Boot to Next.js and Node.js. E-commerce platforms can migrate from PHP to Next.js with MongoDB. These templates help structure different projects in terms of analysis and document management, ultimately leading to modernized code. Team Views and Calendar Integration. The dashboard includes comprehensive team views showing member counts and activities. There's also a calendar section displaying current events and today's schedule. For example, you can see a banking review meeting and a CRM architecture discussion scheduled for today. Activity timeline. The final component is our timeline section, which allows you to review what has been accomplished over recent days in terms of projects created and other activities. This dashboard view provides complete global visibility into all modernization activities. Now let's zoom into the three core modules: Discovery, Twins, and Reverse Engineering. Now let's dive into the Discovery module, where the entire modernization journey begins. An application consists of much more than just source code. It includes deployment artifacts, incidents, changes, and other lifecycle elements. Applications are also defined by documentation, multimedia elements, and descriptions from application owners. The idea behind application discovery is to consolidate all these elements into a single focal point. The discovery process includes several key components. First, we select data sources, the repositories and documentation we want to analyze. Next, we choose the AI agents to apply architecture agents, security agents, or others based on your needs. Then we execute the analysis and review results. Looking at our current metrics, 47 analyses have been performed. Of these, 42 were successful, 5 failed, with an average duration of 3.2 hours. We can see 3 applications in the system. The Oracle banking application is completed. The order management system is in progress. The TinyBlog application has failed and needs attention. Configuration is managed through our interface. We specify the Git repository for analysis. We can define technology stacks if needed. Most importantly, we select different AI agents, architecture review, code analysis, documentation agents, based on specific requirements. The estimated total analysis time is 2 hours and 40 minutes. Once launched, analysis duration depends directly on the quantity of documents and lines of code. During analysis, we can visualize what's happening in real time. For the banking application analysis, we see global progress, agent status, and processing stages. When completed, we get comprehensive scoring. For architecture, we see an A- grade with 88 out of 100. Code quality achieved B+ rating. The system provides key findings highlighting important discoveries. We can access specific views on application synthesis. This information serves for documentation purposes later. The system identifies action plans based on what needs implementation if keeping the application as is. The platform provides complete traceability for any application across different analyses. Analysis B from February is compared to Analysis A, showing evolution and indicating changes occurred. We have comprehensive templates for different agents that define analysis scope. The platform includes various integrations: GitHub for source code, Jira for ticketing, and Slack for change communications. Once the Discovery module completes analysis, we can move on to creating the application twin. Now let's switch to the Twin module view. The twin is actually a digital incarnation of the application, an intelligent agent that possesses complete knowledge of what the application is from both functional and technical perspectives. Once we've completed the retro documentation process, creating comprehensive documentation from various elements like source code and other artifacts, we can proceed to create the twin. The twin is fundamentally created from structured question and answer sets, involving both content development and deployment operations. On the left side, you can see 3 main sections: the creation section for building new twins, the monitoring and management section for operational oversight, and the configuration section for customization. Currently, there are 3 active twins for our Oracle, TinyBlog, and order management applications. Looking at our metrics, we have 23 twins in total across the platform, with 18 currently active and 15 fully deployed. The difference between active and deployed comes from twins operating in pre-production environments for testing purposes. The average construction time is remarkably efficient at just 12 minutes. When creating a twin, we need to provide several critical elements. We utilize components from the initial discovery analysis in terms of technological content and specify which components we want to deploy. Everything depends on the specific agent type we're creating. In this case, we're building an agent with a knowledge base. There will be 2 knowledge bases integrated. We'll also configure 2 specialized tools. One that connects to ServiceNow to retrieve change-related elements. We could add others for observability purposes, such as Datadog integration. We also include an application expert component, which is the core agent that maintains complete knowledge of all documentation. Next is the infrastructure layer. This defines what we make available for deployment purposes. These are the fundamental technological foundations upon which the twin operates. After establishing infrastructure, we handle agent deployment, which can be versioned with different deployment strategies. In the management section, we have complete tracking of all deployment activities and duration metrics. Once deployed, we can continuously monitor the twin's health status to ensure it's functioning correctly. The agent has built-in observability capabilities providing real-time insights. We have comprehensive logging elements for troubleshooting, and we provide pre-designed twin templates with predefined structures in terms of knowledge bases and tools. The final element is advanced configuration, which allows detailed modification of different twin elements. Once the twin is successfully deployed and operational, we can move forward to the reverse engineering section. Now we're moving to the final module, which is the reverse engineering module. This module will prepare the documentary workspace that we'll see later, on which we'll work to recreate the proper documentation of the application. Reverse engineering overview. Here we can see a total of 23 workspaces that correspond to as many applications, with all the people who collaborate on them. There are many more collaborators than before since we're now working on creating the documentary campus that will serve for redevelopment purposes. We can see that approximately 1,300 pages have been created by AI to define the complete application landscape. We find our familiar applications here, the banking system, TinyBlog, and OMS, as well as all the activities that have been performed recently, particularly around authentication components. Specialized tenants and collaboration. The workspaces are actually specialized tenants for each of the applications, which we'll explore shortly. These tenants are directly connected to the agents so that teams can interact with them seamlessly. We find all the classic elements of a collaborative environment. Content shared with me, recently modified items, and various favorites that users can maintain. In the collaboration design, we have a number of pages that are created. A page is an element that we'll see later as part of the tenant structure. Workspace creation and templates. We can create new workspaces, spaces organized by application as we saw earlier, which are focused on knowledge and documentation concepts, essentially functioning as a team wiki. Obviously, we have a number of templates that exist to simplify the creation of these workspaces. Then we have all the standard collaborative activities where we can see who did what and what was created. This is also a complete collaboration platform designed to recreate application documentation in preparation for modernization. Collaboration features. We find the history, shared pages, and all the sessions that have taken place, which are live exchange sessions. We also have a number of AI-generated contents that are made available in terms of architecture and media elements as well. We'll find a number of elements that can be integrated into the collaboration platform, including embedded sources that can be placed directly into different pages. These embeddings provide direct access to source materials within the documentation workflow. Integration with application teams. Once this is completed, we'll switch to the final element, which is the utilization of the collaboration platform by application teams to recreate comprehensive documentation. This reverse engineering module serves as the foundation for rebuilding application knowledge and preparing teams for the modernization journey ahead. Now we'll conclude with the portal that is used directly by end users. These are not the people who performed the reverse engineering, but those who collaborate on the application. When we access this portal, we'll find several workspaces that we just saw, including one specifically for the Oracle application. AI-generated documentation environment. When we enter the Oracle workspace, all these documents have been generated by AI. None of them were created by humans. On the left side, we can see a description of what we've just witnessed in terms of the creation workflow. We create the knowledge base, we create the twin, we create the specifications, we create the user specifications, and then we create the mock-up that you'll see at the end. This represents the actual modernization activity. We find the first documents that are available for the application. Here we can see one of the documents that was made available in addition to the PL/SQL code for the Oracle application. We also have the application twin available. Interactive application twin. Within the twin, we'll find all the elements that were generated to create it. Obviously, if I wish, I can interact directly with the twin and ask it questions. For example, I can ask, please describe the e-banking applications. What the system is doing right now is asking the twin to examine its knowledge base, exchange with the application expert when necessary, and make several requests to retrieve external information. We can see elements related to account management and other banking functions. We're communicating directly with the twin, and this is in French since everything was processed in French, but the same functionality obviously applies when working in English. Creating new documentation. Next, we begin creating new documents following the same principle. These are documents completely created by AI. Here we have the general specifications and we'll find non-functional requirements, functional requirements. Everything is included. Obviously, all of these documents were generated by AI, and then we have detailed functional specifications. These follow the same principle and provide us with various elements. All documents are managed by AI and are readily available. The diagrams are available in Mermaid format and can obviously be transformed. Similarly, if I need to discuss with the agent, I can ask questions like, describe the functional components of the application. The system provides a complete description of all modules, banking operations, account management, everything that goes with it. Everything is well described in the documentation. Technical implementation module. We've completed the new application section. Now we move to a module that will arrive later, which is technical implementation. Here we switch to something more focused on how we'll technically describe the application. We have comprehensive content covering key functionalities, personas, user stories, and functional overview. We also have the capability to describe screens, which will serve us later for mock-up creation. Here we've described all the screens in detail. Screen generation and application development. For each of these screens, we define the generation prompts. These prompts will enable the generation of all the screens behind them. In this case, there are about 15 screens defined. We conclude with application generation. What you see here is the application that has been completely regenerated using the application twin as the focal point, recreating the documents and using Next.js in this case. We're using a code generation platform called v0.dev, which specializes in Next.js applications. Each framework will have its own platform for generating screens. Live collaboration environment. From this point, the work is complete. We can begin working with different business units, propose solutions, and modify them directly live on this platform since collaboration functions exist. For example, if I return to the user experience section, I can create comments, and we're truly in a pure collaboration environment that enables exchange and provides a common work foundation. Complete modernization summary. To summarize this demonstration, we have modules that enable analysis of the existing application, recreation of the twin, recreation of collaboration spaces and documents, and finally the collaboration space that allows teams to work together to modernize the application. The platform provides a comprehensive end-to-end solution, from initial analysis through twin creation, document generation, and collaborative development of modernized applications. This complete workflow ensures organizations can efficiently transform their legacy systems while maintaining full control and visibility throughout the entire modernization journey. Thank you and goodbye.